Hello, class 10. So we'll be going through the same topic which we did the last whole week, which was waste management. Last week I had told you to read through some of the pages of your last chapter and also had given you some homework. But I felt this is a very important topic, even though it's about pollution and it's about how to manage waste. It's really important about understanding that this is one of the most easiest chapters for you to choose for your boards and easiest chapter for you to understand and to score marks as well. So let's break down the word waste management. So it is just a combination of two words, waste plus management. Waste is something which is not usable. We don't want it. We just want to throw it off. But at the same time, management is a word which describes a proper way to utilize something or a proper way to decompose or a proper way to manage. So these two opposite words kind of go hand in hand in this topic where you are trying to use or you're going to transform or you're going to change something which is totally useless into something which will be beneficial for the society. So in this video, we'll just be looking at the causes and the impacts of waste management. There will be another video which will be uploaded soon, which will be about the remedies which we can take and what are the proper ways in which we can manage waste. So this video is just about if waste management is not done properly and waste is just dumped, what will be the impacts it will create and what are the reasons that push us to do waste management, because we see waste all around and we really want to do proper waste management. So this video is just about the causes and about the impacts. So let's go into the what do you guys think is waste? If we had to have a definition of waste, what do you think is waste? Waste can be considered anything which is unwanted or unusable. So what is the first thing that might come into your mind? A torn cloth, a used pencil, pen, or once you consume any eatable, the wrapper. So once something becomes unusable or unwanted, it automatically transforms into waste. What are other things which can be classified as waste? Any substance which is discarded after primary use or is worthless, defective, and of no use. You take a dot pen, once the ink is complete, once the primary use is over, it automatically becomes worthless. You buy a t-shirt, you use it for 2 years, 3 years, then the stitches go off or it's torn or there's some holes in it. You try to stitch it or you try to make it better and you reach a point where it can't be made better. It is classified as defective and hence you can't use it. There's no use and hence it is discarded. That also classifies as waste. And this, the third point, a byproduct of a relatively minor economic value, is also very important. For example, when we transform sugarcane into sugar, there's a byproduct which is the fibers of the sugarcane, which can be transformed into a fertilizer, which can be transformed into some other materials which is used in paper industry, pulp industry, or manure, be transformed into manure or fertilizers. But the economic value of that product is very less. So most of the time when sugarcane is made out of sugar is made out of sugarcane, the byproduct or the fibers is not transformed into a fertilizer because it doesn't have much economic value. So when you look at a sugarcane and when you look at the fibers of sugar, obviously the fibers of sugar doesn't have any value. Even if it can give something useful after a transformation, when you hold it, you don't feel it valuable. So it is a byproduct which is having minor economic value. Hence, it automatically classifies as waste. There's an interesting thing that's later on the bottom. Yeah, there's a country that wants your waste because they have ran out of theirs. We are living in a country where there's so much of waste and we don't know what to do. But here is a country who have consumed all of their waste because they've done something useful out of it, and they're actually asking other countries for their waste because they've ran out of theirs. So I want all of you guys to think about which country it would be. I'll give you a clue. It's a country from Europe. It starts with the letter S. Okay, I hope some of you were able to guess it. So this is the flag of that country, and it's Sweden. So let's see what they actually do.
Nameless. 2 billion tons of trash are dumped into landfills every year around the globe. That's so much trash that if you lined it up in garbage trucks, it could circle the Earth 24 times. Wow. But Sweden has found a way to make their trash work for them. By using it to fuel a waste-to-energy program that converts garbage into sustainable energy. Sweden has even gotten so efficient at this process that they've run out of their own trash and now import garbage from other places. Believe it or not, only 1% of Swedish garbage actually ends up in a landfill. So where does it all go? About half, or 47%, of Sweden's waste is recycled. The program recycles and sorts metals, plastics, newspapers, batteries, and electronics. The remaining 52% of the country's waste, like excluded scrap metal, circuit boards, and agricultural waste, is used for the country's waste-to-energy, or WTE program, which produces electricity from burning waste. So all that remains is a remarkable 1% of Sweden's trash that actually ends up in a landfill. But wait, how exactly does garbage turn into energy? After recyclable content has been removed, the remaining trash is brought to a waste-to-energy plant. There, the trash gets loaded into furnaces and burned, which generates a large amount of steam that spins generator turbines, producing electricity for the nation's power grid. All leftover metals are separated and recycled, while any other remaining materials that do not burn, like porcelain and tile, are collected and repurposed into gravel for road construction. Over the past decade, Sweden has become so good at this waste-to-energy process that they've actually run out of their own garbage and had to start importing it from other countries. It's a win-win situation for most countries, since shipping trash to Sweden is not only cheaper than paying landfill taxes, but it also makes sure more garbage is reused. In 2014 alone, countries like the UK and Italy exported about 2.3 million tons of waste to Sweden's WTE facilities. Those factories charge about $43 per ton of trash, meaning that for those 2.3 million tons, the country made almost $100 million in revenues. Day by day, Sweden gets closer to becoming a zero-waste nation, with efforts both large and small. Their waste-to-energy program has even inspired other countries to consider it for themselves. Do you think a waste-to-energy program would be beneficial in your country? If you're looking for more ways to help save the world, click the subscribe button. Or if you want more videos from Save the World, click here to keep watching.
Okay, that video was really inspiring because in a country like ours where we find really so much waste when we don't know what to do, places like Sweden, they have transformed something which is a burden into something that works for their good, for their benefit, and they're even making so much money by importing garbage from other countries and just transforming it into energy, and the country is running a huge large chains of power supplies with the help of that. So for those who didn't understand that video, it was just about Sweden segregating or separating their waste into three categories: into one category which can be recycled, into another category which cannot be recycled, into the third category which doesn't fit in either recyclable or non-recyclable. Okay, the first category which can be recyclable will be metals and will be wooden things, or will be any paper related scrap which can be recycled. So they remove the recyclable material and they send it for recycling. That's about 40 to 45 percentage, and another 45 to 46 percentage or 50 percentage will be the things which are non-recyclable, which can be burnt directly, and it produces so much steam, and the steam helps in rotating turbines, and the turbines which rotate obviously run generators, and the generators which produce electricity, and the electricity goes to the power lines and lights the country. What about the remaining 3 to 4 percentage? These are things which can not give steam if it's burnt. At the same time, it will not be recycled also. It cannot be recycled also. Those are the things which are broken down and are mixed along with sand or mixed along with soil and are used for laying roads. So ultimately they get only 0.5 to 1 percentage of waste out of the 100 percentage which they actually dump into land. In our country, 100 percentage waste, 95 percentage is dumped into land, and hardly 5 percentage get recycled, and there's no energy which is produced. But in a country like Sweden, it's the opposite that happens. Just 1 percentage or less than 1 percentage gets dumped, while all the other 99 or above 99 percentage gets used in an effective way for the country. So if it's not been done, for example, in a country like us, there are a lot of impacts that happen. What are the impacts? The fundamental or the first important impact is the spoilage of landscape. The land is dumped with waste, and it doesn't look good for the eye. It doesn't look good for the people living around. There's a lot of health related problems that create. There's so much pollution that occurs if when people burn it, when people dump waste into the water bodies, when people dig a hole and dump it inside deep into the soil. It affects the soil also, and it creates an environment for, or a breeding ground for, all kinds of vectors, all kinds of bacteria and viruses for outbreak of new diseases. So it doesn't just affect terrestrial life of humans by creating new diseases, it also affects the birds, it also affects the animals, and also affect the aquatic life of ponds or lakes or rivers. So moving into the first one, spoilage of landscape. What fundamentally happens? The solid waste from our homes or from industries or from factories or from big places are dumped just because they're not decomposed or they're not recycled. Then nothing else is done. So just they are left over for something to happen on its own. And ultimately nothing happens on its own. It stays there. And most of the solid waste which we produce in our country is plastic, and that doesn't decompose, and it stays and it spoils the landscape. If it comes in contact with open surface water like a pond or a lake or a river, it affects the surface water, and that seeps down and connects with the ground aquifer, and it affects the groundwater as well. Surface water pollution creates a very good breeding ground for bacteria, virus, and other vectors. We know that vectors are nothing but any organism which is capable of transmitting or transferring a disease from one place to another, transferring a virus from one place to another, from one person to another might be a vector. Mosquito is a very good example of vectors, and you know that mosquitoes find open water sources where there's pollution as their best breeding grounds to multiply and grow more. Increases chances of a disease outbreak. Once a disease starts, it just spreads, multiplies more and more in areas where there's more pollution. What happens when there's a lot of air pollution and a lot of condensation takes place in the clouds? Eventually, it builds up, and all these harmful gases come down as precipitation in the form of acid rain. And this acid rain mainly affects buildings which are rich in calcium, limestone buildings, and buildings made up of marble. Both are rich in calcium, calcium carbonate, and it easily gets corrodes corroded by acid rain. Taj Mahal, we know that the color of Taj Mahal has faded and it has become more browner recently, mainly because of the toxic gases that surrounds and also because of acid rain that has happened quite a few times in those areas. And another picture over the bottom left is a picture of a landfill, and you can see this is pretty common in our country. We see that every here and there. It's mainly because we are not segregating the waste and we are not having a proper plan to decompose or recycle things which cannot decompose things which can be decomposed. If there's a proper planning of segregating and recycling and decomposing waste, these kind of landfills. Point number two, pollution. Pollution means to degrade or reduce the quality of a body or an area, mostly done by human beings, but occasionally natural as well. So we must not come to the conclusion that human beings are the only reason why pollution happens. It can occur natural as well. For example, a volcano can create a huge amount of air pollution. A landslide near a river body can create a significant amount of water pollution. And there are many other ways in which soil pollution also can take place naturally. Waste accumulation is the most common form of pollution. Even though there are natural ways in which pollution takes place, the most common way of pollution taking place is through human beings and is through us dumping waste or accumulating waste. Agriculture and food processing industries are the largest and biggest contributors of solid waste. So if we classify solid waste and liquid waste, solid waste mainly comes from agriculture industry or food industry, while liquid waste mainly comes from factories or industries which produce chemicals or pesticides or petrochemical products, plastics or petroleum related refineries or oil rigs, all these places where there is a lot of refining taking place and energy being produced, there is a lot of slurry and there's a lot of liquid waste. Eutrophication is one of the most significant effects of water pollution, which we'll be learning in the next slide. What is eutrophication? Eutrophication is a process which is a resultant of water pollution, and it eventually leads to the depletion of oxygen in an aquatic water body, and it later results in. So this is what happens in eutrophication. You have to notice that this picture has two or three important terms. The term in the top left, nutrient intake, the term in the middle, which is algal bloom, and the term on the right, solar energy, and the term at the bottom, scarce oxygen content, are the four most important terminologies which are need to be known for this eutrophication process. So nutrient intake is nothing but pesticides and fertilizers which are sprayed in agricultural fields is washed away and reaches the nearby water body when there's a rain. And here there are a lot of microorganisms called phytoplanktons or zooplanktons or many other kinds of microorganisms which survive on the surface are waiting for this nutrient to grow and develop. And they get these nutrients from the fertilizers and pesticides and they multiply, they grow and develop, and they start to cover the water body to the point where you can never see the water. You would have seen these kind of water bodies in and around your locality where the whole water body is completely green in color. You would have seen something like this. And this mainly happens not overnight, but it takes 2 weeks or 3 weeks or 4 weeks for the algae to double and multiply with taking all the nutrients inside. Once it has covered the whole water body, it directly reduces the amount of sunlight that enters inside, and when it has completely blocked the contact of water with the atmosphere, it automatically reduces the oxygen content also inside. So when sunlight and oxygen is reduced, automatically the aquatic animals living inside will eventually slowly start to die. So effluents and nutrients through fertilizers from agriculture fields increases the growth of algae and phytoplankton. This covers the surface of the water body. Penetration of sunlight, oxygen, and heat is also reduced. This results in the death of most aquatic organisms. So this process together is called eutrophication. There are a lot of health hazards also that take place because of pollution or because of improper waste management. health hazards like nerve problems, like eye irritation, like hypertension and fast pumping of the heart, like respiratory problems of coughing or lung related problems, or even genetic and mental disorders are one or few of the many health hazards that can happen if there is no proper waste management. The first one is mainly caused by a chemical element lead, which mainly affects the blood system and the bodily and mental behavior. Cadmium is also a very harmful element which can affect the kidney, cause hypertension in the heart, and can in severe way affect the cardiovascular or heart related uh, areas and cause related problems. Nickel is also another element which affects respiratory problems. Mercury, it affects nerve and brain, while beryllium is another element which can occur in and around improper waste management areas, and it can affect the eyes, heart and lungs. So you guys will be wondering, where do you get lead, cadmium, nickel, mercury and beryllium? Our daily products don't have lead, cadmium, nickel, beryllium and mercury and all the other harmful elements, but these are mostly found in hardware, like the parts of a mobile phone, the parts of a computer, inside machines, or in televisions, or any gadgets or electronic devices which are hundreds and thousands being used in every day. Once it's disposed, all these elements are out, and all these elements are into the atmosphere. If you don't take these electronic gadgets, it can come also from factories, from industries, from places where huge amount of harmful gases are pumped out, and it can also come from vehicular pollution. From the vehicles we use lead and mercury all the time, it is pumped out through the silencers. So even though we are not in direct contact with lead, nickel, mercury, beryllium and cadmium or other elements, we are every day releasing these kind harmful elements into the atmosphere, and it, if not properly managed, will severely affect our body system. Among these five elements, take note of the word mercury, which affects the nerve and brain, because you'll be watching a very important video clip which is called Minamata disease, which affected a place called Minamata Bay in Japan due to mercury being added or mercury being disposed into the Minamata Bay from a nearby industry, and the fishes consumed that, and the fishes were consumed by the people, and that led to mental and nerve related problems for the people living in Minamata in Japan. So you'll be watching a video related to that, so that will give you a better understanding of how improper waste management can lead to severe health hazards. And there's also one more, which is asbestos, which we use pretty common in our country for roofing and tiling and all the construction related works, that has fine particles which can enter a body and affect lungs and cause chest related problems. Okay, what effect does it have on terrestrial life, like humans, birds and animals? For humans, we know that it affects our body. Just the previous slide we went through all the diseases that can happen. It affects humans on an everyday basis. But what about plants? Plants gets affected as photosynthesis is blocked, growth, transpiration and development of stem, roots and the other parts of the plant is also affected. So this is how the leaves of the plants get affected because of the amount of harmful elements present in the atmosphere or the soil or the water. Animals, on the other hand, can consume plastic or some hard waste, and it can choke them and lead to death, or can give birth to retarded offspring or offspring which are not healthy. Birds feeding on agro waste products produce defective shells. Or nowadays, when you crack open a egg which is from cages or which is from the market, it's just not the brown egg, the white egg which I'm talking about. You crack open it, sometimes you might find two yolks, or sometimes you won't find a yolk because it is artificially created, or the kind of food materials which is which these chickens are made to feed on, result in them producing these kind of defective eggs. Dogs, cats, pigs, cows are also affected when it comes in contact with these kind of solid gaseous waste. So there's also an extra information. The Great Pacific Garbage Patch is a huge garbage patch found in the Pacific Ocean. It is found as circulating ocean gyres, which means a huge patch which is circulating in the clockwise and anti-clockwise direction. It moves in that direction in the Pacific Ocean with respect to the movement of the ocean waves. So how did such huge amount of waste end up in the Pacific Ocean? It's the answer is very simple. We human beings dumped all these things in the ocean, and it has come to the point where it has formed a huge garbage patch in the Pacific Ocean. It's found in the eastern side of Pacific Ocean, close to the coast of North America. So here you can see the Pacific Ocean, where you see China and some parts of Asia on the left, and the western side of United States of America and the North American continent on the right. So between the whole these two continents lie the biggest ocean in the world, which is the Pacific Ocean, and you have a western garbage patch and you have an eastern garbage patch. And the most shocking thing is both these garbage patches are also connected together by a you can see the subtropical convergence zone, which is written there. It is actually a zone where wind movements converge from the northern hemisphere and from the southern hemisphere, and this wind movements is actually taking the garbage from the western patch and the eastern patch and forming a belt. So that is the third point, which is written. A conveyor belt, a long conveyor belt like patch connects the smaller eastern and western patches. So there's another picture of this long conveyor belt where you can see in the Pacific Ocean. It's really disturbing to see how much negative impact we have created on the aquatic life. Imagine if this is the place where we used to live, would we be comfortable living in the midst of all these dump? But that's exactly what we have done to all the aquatic animals living in the Pacific Ocean. So this is Pacific patch. So if this has happened in the biggest ocean in the world, how significant is the effect of improper waste management on aquatic life? One of the most strongest point is biomagnification. Biomagnification is just the increasing or magnification of toxin level along a food chain. Always remember the word along a food chain. So when you go from the smallest organism to the biggest organism along a food chain, from a microorganism to a small fish to a bigger fish to a much more bigger fish, and finally we consuming the fish. So along this food chain, the toxin or the poison level which was consumed by the smaller organism gets doubled when it's been consumed by the bigger one, gets 3 times higher when it's consumed by the next organism, and when it reaches the last consumer, which will most probably be human beings, it comes at a 10 times or 5 times higher rate into our body. So biomagnification is the increasing or doubling or magnification, however you can put it, of toxin level or poison level along a food chain from the lowest to the highest, or from the producers to the tertiary or final consumers. Tertiary consumers can be used only if there is only three consumers, but the word beyond is used to make you understand that there can be beyond three consumers. The food chain can start from one organism and can be consumed by a 10th organism or 15th organism. That's so it will be the 15th consumer or the 16th consumer. If it ends with three consumers, it's tertiary consumer. If it goes beyond that, you can give the number with respect to which consumer it is. Humans are also affected in this process if they are the last consumers in the food chain. This most probably happens when we consume aquatic animals and those aquatic animals have consumed smaller aquatic animals, and there has been a toxin level. It magnifies along the food chain and it comes to humans at the highest point. So here is a picture which clearly indicates from water to plankton to aquatic insects to insect eating fish to fish eating fish to humans. So the mercury concentration or any other toxin level, if it's lead or if it's cadmium, if it's beryllium, if it's anything else of a harmful element which has been inside water and mixed with water, if it's been consumed by a smaller organism, it automatically magnifies when it goes along the food chain. Here is another pictorial representation where you can see how it multiplies 1,000 times and becomes 10,000 and becomes a lakh and a million and a billion times more and more as it goes through the smallest to the biggest, or through the producers to the last consumer in a. So this is the video I was talking about related to mercury being added or being poured out as waste in a place in Japan called Minamata and how it affected the lives of the people over there.
It is now 50 years since the most horrific mercury poisoning disaster took place in Minamata, Japan. Minamata is located on the coast of Japan's westernmost island. The city and the adjacent Minamata Bay form a relatively close ecosystem. The bay was a source of fish and almost the city's exclusive source of protein until the mid-1950s.
Minamata is a small factory town dominated by the Chiso Corporation. The town faces the Shiranui Sea, and Minamata Bay is part of this sea. In Japanese, Chiso means nitrogen. The Chiso Corporation was once a fertilizer and gradually advanced to a plastic maker company. From 1932 to 1968, Chiso Corporation dumped an estimated 27 tons of mercury compounds into Minamata Bay. The town consists of mostly farmers and fishermen. When Chiso Corporation dumped this massive amount of mercury into the bay, thousands of people whose normal diet included fish from the bay unexpectedly developed symptoms of methylmercury poisoning. The illness became known as the Minamata disease. The mercury poisoning resulted from years of environmental destruction and neglect from Chiso Corporation.
The mercury contaminated fish living in Minamata Bay. People ate the fish, were themselves contaminated, and became ill. Local bird life as well as domestic animals also perished. In all, 900 people died and 2,265 people were certified as having directly suffered from mercury poisoning, now known as Minamata disease.
Methylmercury concentrates in neural tissues, which explains why neurotoxicity was the major adverse effect observed in Minamata Bay. Offspring of Minamata Bay residents afflicted with Minamata disease also exhibited neurotoxicity because methylmercury can be transferred across the placenta.
At the time of this poisoning, household animals began to exhibit behavior too,
in which cats living in the cities would ultimately throw themselves into the bay in order to prove or disprove that industrial waste from the Chiso factory was the culprit in Minamata disease. A total of 10 cats were fed food mixed with industrial waste. Characteristic lesions of methylmercury poisoning were observed in the central nervous system, and the mercury levels in the cerebrum, liver, and kidney were found to be markedly elevated in these tested animals.
In the early 1950s, sometime later, similar behavior began to appear in humans.
The physiological effects, including successive loss of motor control, were devastating and resulted in sometimes partly paralyzed and contorted bodies. The methylmercury that enters the body mainly attacks the central nervous system, including the brain, and causes various symptoms including numbness and unsteadiness in the legs and hands, tiredness, ringing in the ears, narrowing of the field of vision, loss of hearing, slurred speech, and awkward movements. Some early severe victims of Minamata disease went insane, became unconscious, and died within a month of the onset of the disease.
There are also victims with chronic symptoms such as headaches, frequent tiredness, loss of the senses of smell and taste, and forgetfulness, which are not easily visible but make daily life difficult. Chiso, as it had since 1925 when the incident happened, continued to pay indemnity.
So I think that video was really painful to watch over towards the end, but we can be really thankful that the same thing didn't happen in our country, even though we dump a lot of liquid waste which includes a lot of harmful chemicals like mercury and lead or cadmium or other harmful elements into water bodies, we haven't faced such a severe health hazard. But this is what that can happen if there is improper waste management. Improper liquid waste management can cause a huge impact, a huge health hazard, such big as the Minamata disease. So let it help us to understand that we must be really careful about how we segregate solid waste, liquid waste, and gaseous waste, and how we make sure that harmful elements do not reach the Earth's soil or water or Earth's atmosphere. Talking about Earth's atmosphere, just like water, there are a lot of harmful chemicals that we emit into the Earth's atmosphere, which include carbon dioxide, which include methane, chlorofluorocarbons, and when in extreme high amount, water vapor also acts as a greenhouse gas. Greenhouse gases are nothing but gases which are emitted from the Earth's surface outward towards the atmosphere, but these gases just cling onto the troposphere or the lowest layer of the atmosphere, and they don't allow the terrestrial radiation, which is the reflection or which is the return of the solar radiation or sun rays from the earth back to the atmosphere. So from the earth, a majority of the solar radiation which came towards the earth has to go back, and it doesn't go back fully and gets trapped within the troposphere because the troposphere has all these greenhouse gases, and hence it slowly starts to increase the surface temperature of the earth, and that is called global warming. So any gas, harmful gas which is released from the earth's surface outward to the atmosphere, which gets stuck in the troposphere, which in turn prevents terrestrial radiation from moving out, and which in turn increases the surface temperature of the earth, is called global warming. And the gases which start all of these, like gases like carbon dioxide, methane, nitrogen oxide, chlorofluorocarbons, and high amounts of water vapor, these can be categorized as green. So here you can see two pictures, especially in the second picture over here in the right. You can see natural greenhouse effect, which happens on a normal basis, and human enhanced greenhouse effect, which happens often. Nowadays, this is what that happens. It's human enhanced greenhouse effect, not the natural one, because of the high amount of nitrogen dioxide and methane and carbon dioxide and all the harmful gases which we emit from the surface. It is trapped within the troposphere or the lowest layer of the atmosphere, and it doesn't allow the re-radiated heat, which is, in other words, the terrestrial radiation, to go out. And you can clearly see that in natural greenhouse effect, there is more heat that escapes back into the space, while in human enhanced greenhouse effect, you can see that there is less heat escaped into the space because these harmful gases are trapping the heat and not allowing it. So it will obviously increase the surface temperature because it gets reflected heat back and forth within the troposphere. It increases the surface temperature of the earth and thereby forming global. Another very important thing that occurs during this gaseous improper waste management, or if harmful gases are not properly filtered from factories or industries or from a lot of machines, it can release chlorofluorocarbons, which is the major reason for this phenomena to occur, and it is called ozone layer depletion. You would have heard about this quite a lot of times through your 7th, 8th, and 9th classes. And this is when ozone layer, which is formed mostly in the second layer of the atmosphere in the stratosphere, which is consisting of ozone molecules, which are three oxygen molecules together, and these oxygen molecules, which are three combined together, forms the ozone or O3 molecule. When a chlorofluorocarbon molecule, which is three chlorine, one fluorine, and one carbon, combines with one of the oxygen molecule of O3, and it tries to separate the O3 molecule into a chlorine and an oxygen, and another oxygen and another chlorine, another oxygen and another chlorine, or it combines two oxygen and it combines the remaining one oxygen with a chlorine, or it does any of different way of the combination. What is actually it is doing is that it is splitting apart the O3 molecule into O2, or it is splitting apart into O. So it is making the ozone layer thinner and thinner. We usually hear the word ozone hole, but it's actually a misconception that there's a big hole over there. The ozone layer thins or becomes thinner and thinner when there's a lot of chlorofluorocarbons emitted and when chlorofluorocarbon molecule interacts with the ozone molecule. In the next slide, you will see a video where there's a beautiful illustration of how this chlorofluorocarbon molecule interacts with the ozone molecule and makes the ozone layer thin.
15 to 35 kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
Okay, the good news is that the ozone hole has actually started to reduce in size, and just like how that video ended with the Montreal Protocol, which was a meeting where a lot of people who were really concerned about the environment came together and decided that there's not going to be any more CFCs or any more fluorine and chlorine included products of which is used in everyday or normal use, which is going to be sold. If those kind of products are sold, it will be banned. So a lot of strict decisions were taken and a lot of products removed chlorine and fluorine from its ingredients, and it really started to work to the point where in 2020, which is the year we live in right now, and 2019, which is the previous year, in the last 2 years, there has been a significant change in the ozone hole or the ozone thinning, where all over Antarctica earlier there was a huge circular patch where there was a very thin layer of ozone, and all the other parts around surrounding the globe there were thicker layers of ozone here. But it has drastically come down, and you can see that in this video. So this will be the last portion of this video, which we talked about the causes and the impacts of not having proper waste management. So we're going to end it on a good note by understanding that reduction of chlorofluorocarbons has significantly changed the ozone hole, and it has brought it down to a very small level.
Every day, as the sun shines on the Earth, it sends ultraviolet rays that can cause sunburn and sometimes damage our DNA. Like a sunscreen for our planet, the ozone layer absorbs most of this harmful radiation and protects us. But in the early 1980s, scientists discovered that the ozone layer was thinning over Antarctica each August and September. In 1987, nations around the world came together to fix the problem through the Montreal Protocol. The international treaty banned the production of ozone-depleting chemicals like chlorofluorocarbons, or CFCs. But these chemicals had been in use for decades, and they stay in the atmosphere for a long time. So, it took a while to see the effects of the ban. In 2000, the ozone hole was the largest ever observed by scientists. But conditions slowly improved. Data from NASA and several partners show a 20% decrease in ozone depletion during August and September from 2005 to 2016. In 2017, the hole is the smallest since 1988. A year later, the hole was smaller than expected. Studies suggest that the ozone layer over Antarctica should mostly recover by the middle of the 21st century.